In this video we're going to learn how these special angles in trigonometry are calculated. You don't have to be able to reproduce this exactly yourselves, but it will be helpful if you understand where they come from. It is just good enough to learn the angles off by heart. The first triangle we're going to look at is the equilateral triangle, where each side is of length 2. So this side is 2, and then we're going to split it in half down the middle here. So this is length 1, and then using Pythagoras, this length here is going to be root 3. Now, because it's an equilateral triangle, this angle here is 60 degrees, and the one up here is 30 degrees. So we're going to have a column for degrees, radians, sine, cosine, and tangent. We've got 30 degrees for up here, 60 degrees for down here, and the corresponding angles in radians are going to be pi by 6 and pi by 3. Well, sine of 30 degrees, we're going to start here, so it's opposite over hypotenuse, 1 over 2, so it's a half. And sine of 60 degrees starting here, it's going to be opposite root 3 over hypotenuse, 2, root 3 over 2. Cosine of 30 degrees, well, that's going to be here, adjacent over hypotenuse, root 3 over 2. And then for 60 degrees, or pi by 3, it's going to be a half in the same way. For tan, well, tan of 30 degrees is going to be the opposite over the adjacent, which is 1 over root 3. And if we want to put that in third form, we multiply the top and bottom by root 3, and we'd have root 3 over 3. And then if we want tan of 60 degrees, starting here, it's root 3 over 1, which is just a straight root 3. The second triangle we're going to look at is the right-angled isosceles triangle, and that makes these 45 degrees, and they're going to make these length 1. So we've got 1 and 1, so using Pythagoras, this length is length root 2. And again, we've got degrees, radians, sine, cosine, and tangent, and that's going to be 45 degrees, which in radians is pi by 4. So sine of 45 degrees, if we take the angle here, is going to be the opposite over the hypotenuse, which is 1 over root 2, but if we want that in third form, we multiply top and bottom by root 2, and we get root 2 over 2. Well, cosine, it's going to be exactly the same, because it's going to be adjacent, still 1 over root 2 there. And tan of 45 degrees, which is opposite over adjacent, 1 divided by 1, which is 1. Now for this video there is no worksheet to go with this. You can either learn these angles off by heart, learn to reproduce them yourself, or you could learn what root 2 over 2 looks like when you get an answer on the calculator, or root 3 over 2, or a half, although I'd like to think you know that, and learn those instead. But either way, these angles are important and they help us give exact answers. I hope you found this video helpful. Staying in field with Winfield.